So ACI, there's another thing, ACI Anywhere, which basically meaning that you can have a public cloud, or you can have a remote location where there is a remote leaf and virtual pod concept is there. And API multi-cloud extension, meaning a Google Cloud Platform or an Amazon Web Service or Microsoft Azure. Basically, how you do it. So all the policies which you have in your on-premises data center, the same policy you can put into the Google Cloud, right? So for example, we called as a VRF, right, which is a VPC for a cloud, right, which is a VPC for a cloud. Similarly, we called a tenant for a separate policy or separate this thing. They called node, maybe a node for a cloud, right? So meaning the terminology it's different, but the concept wise remains same. So if you understand the ACI, you will very easily understand the Google Cloud networking or Microsoft or Amazon networking, right? So the concept wise, the terminology wise, the naming convention may be different, but the concept remains same in the Google Cloud, right? So the policy which you created in your premises will be applicable in the Google Cloud if you're using a multi-cloud extension.
Are the cloud teams are also using the ACI in their environment?
No. Why would Google want to use Cisco one, right? But there is a plugin which you can install in the Google, which basically, let's suppose you are creating a VRF here, right? And you want the same VRF to be created on the Google Cloud, but in Google Cloud there is no VRF, there is a VPC, right? So it will create a VPC in the Google Cloud at the same time. So you want one data center on your own premises and backup, or maybe DR in the public cloud, or maybe you need a same set of policy in your on premises as in your public cloud, then you can do it. But you need to connect one plugin to the Google Cloud Platform, and then all the policy you can import from your on premises to the public cloud. Okay, so
Deepak, so I mean on the cloud, once it's connected, right? So I mean it will be the interface of the APIC will be same as we are doing on the on premises.
So in on public cloud, you need to install the APIC on their VMs, on their compute. So there is a software OS which is provided by the Cisco. You need to install that APIC OS. Basically, that's the plugin which you need to install on the.
And the spine and leaf will be on the on premises, or that also we need to create it here on the public cloud?
No. So that's the benefit of the public cloud, right? You don't need to manage the spine and leaf architecture, right? So you just what you need a one VM. Okay, you need a one VM. We will give you the one VM. Now what you want, that this VM should be in this VRF, in under this VLAN, under this tenant, right? This is your requirement. Now this all thing you have already created in your on premises. Now let's suppose there is a one server. This is the server. Now this server is in your on premises. This is in VLAN number 10. This is under VRF A. This is under tenant, let's suppose tenant T. Now you want to migrate this server from on premises to the public cloud, or let's suppose you want the same server on your on premises as well as in your public cloud. Now either use the terminology of the cloud, right? The cloud are using, okay, this is in this VPC, this is in this node, this is in this compute network, and blah blah blah, right? They have their own terminology. Now you are not comfortable with that terminology and you want to use the terminology which is in Cisco ACI. Okay, this is in this tenant T, I want this is in the tenant this one, because I already created on premises, right? Why should I create a separate policy on public cloud, right? So you want to use the same policy which you have in your on premises in your public network. So what you will do, you will the Google will give you the VM. Now you need to put this VM into this tenant, into this VLAN, under this VRF, under this tenant, right? So this basically this epic will do it, right? So otherwise the Google will tell you, hey, this is VLAN number 20, or this has network 10.1. It will create its own network basically, right? You don't want to do that. You want to create the same network as like in your own premises, because you are familiar with your own premises network. You're not familiar with the public cloud terminology, right? But Cisco is saying, okay, you are familiar with your own premises. We will map this with the public cloud, and so that the engineer understand it, right? Basically that will do it.
Okay.
So the virtual machine that we spin up in the cloud, right?
Yes.
IP address will be still in the cloud, or how is it?
Yes, IP address or subnet will be on the cloud. Yes. Now in some cases, Google Google will give you the private IP address, right? And then one public IP address through which the traffic will be routed from public to the private. It will do the netting. Now, similar way we do it in our own premises, right? We have our own private network, and then we do the netting so that the external customer can connect it. But regarding your question, IP addresses, yes, Google will tell you, hey, this is the IP address, but you are saying, I want to use the same IP address, then you can use it, because it's a two different separate private network, right? But if you want to connect it private to private, then obviously you will use a different subnet.
Yeah, what I'm not understanding is the policy that we define in APIC, right, on-prem. It's all based on EPG, tenant, and other things.
Right.
How are we able to relate that with the cloud? How is that possible, right? Because cloud, it's all totally different, right?
Yes, so that's what I'm saying. That only the naming is different. So VRF is in your ACI, VPC is in your cloud. And actually, I have one slide which I have taken from the Cisco Live. Let me see if I have shared with one of my teammates a few days ago.
Yeah, I understand. We are installing an APIC in cloud, and we are using the same policy, right? How is that translating to that cloud? Like if I take Amazon, you have VPC and you need a EC2 instance, right?
Right. Yes.
How is that relating to it? Like, how can we use the same policy in cloud? I mean,
yeah. So I'll share you that slide. I don't want to waste that time in order to search, but there is one comparison which Cisco has done. See VPC here, VRF here. This thing here in the Google Cloud, this thing in the ACI, and basically we are doing this conversion. So very nicely they are doing it. I will share with you that slide.
okay. And another thing is about the APIC, right? Any license requirement for the APIC?
Right.
Those...
Yes.
Okay.
Yes.
Gonna,
and that. Sorry.
So you can explain in the upcoming slides, or it's gonna...
No, actually not. Actually, recently I was involved in one of the project where we are migrating some server from our on premises to the Google Cloud. At that time, I learned this thing, and at that time we basically did not use the Cisco ACI APIC on the Google Cloud. We use the Google Cloud terminology only. But we shared this project with our manager as well, like, hey, whatever the policy we created on our own premises, we will create it on the Google Cloud with the help of that cloud extension. And that time we asked Cisco that we need the license. Yes. And actually the OS which they are spinning up in the Google Cloud for the APIC OS, it will charge a very high amount to us, right? So that's why we thought maybe as of now we don't want to go with that. Let's try to do the Google Cloud public to private cloud integration without the APIC OS. Okay, so
my question is specific to on-prem, right? If we have 3 APIC, if you have to purchase 3 APIC, are there any license associated to those APICs?
Right. Yes.
So how does relate to? I mean, like if I have to think about spines and leaf, based on that, I have to purchase the license, or how is that license for Epic?
No, so for on-premises, no, you don't need that license. I was talking about the Google Cloud, this one.
Yeah, I'm asking about on-prem. Like,
No, on-prem, no.
no license.
Yes, no license. Yes. So when you purchase the Epic, it comes with a 10-year license, but that is auto renewable. It will show you this certification is valid till 10 years, but that automatically renew it.
Okay. And there is no feature set, something like that, like what we have in
No.
We can use VPC, any other feature in all these
Yes.
fabric. Okay.
Yes.
And with respect to design, right? How do I think like, hey, I need 4 spine, 10 leaf? How do I determine that?
So basically, that you do with the like what your requirement is. Meaning generally in the spine and leaf architecture, we maintain a 3:1 ratio. 3:1 ratio meaning, so let's suppose you have a downstream 100 gig of traffic. You have a 10 server connected, right? And all those 10 server will have a 10 gig link. And let's suppose at any time they are sending a 10 gig of traffic, right? So you have 100 gig of traffic which is coming from your downlink to the uplink, right? Now to maintain a 3:1 ratio, 100 gig, right? So 100, if I divide by 30 with the 3, so it will be around 33, right? So I can have a 3 spine will be connected here, or I'll connect a let's suppose let's suppose 50 gig here and 50 gig here, right? So I can do it like this, like 50 gig here and 50 gig here, but recommendation is 3:1, meaning put this 100 gig into this 33 and connect 3 uplink or 3 spine, but you don't need a 1 more spine. You can have 2 spine and then just connect to all the leads. Now the spine, if there's a 96 port, right, 96 port spine, so you can have like 96 leaf connected on your downstream. So it depends on the spine, how many ports of the spine you have. So now if this uplink, yeah, it's just give me 1 minute more. Now this uplink is like 40 gig capacity, right? Now this 40 gig capacity cannot accommodate this 50 gig, right? So obviously if you are doing 100 gig, you will have 1 more link more connected to the same spine or to be different spine. Now you will have 3:1 or that ratio you need to maintain it. Right? So it depends on the uplink port capacity, how much uplink port capacity you have. If it's a 40 gig port, then combine how much traffic is coming on your from your downlink and try to do it 3:1 ratio. If it is not possible, then just do it evenly, meaning with the 2 spine.
If you're saying 3:1, then it's always 3 spines. Like if I take any like if I have 400 gig, right, in the downstream,
yes,
then if I do that same ratio, it's going to be again 3 or 4, right? That's the spine switch. Yes,
3 or 4. Yes. So 100 gig. So I will maybe connect 2 links to each of the spine. So like 40, 80, 80 to 1, 80 to like 320 gig will be to all the spine, and then remaining 80 gig I'll distribute to the other 2 spine. Maybe connect a 1 link here, another link here.
So if I'm designing something for the data center, so then I have to initially find out what endpoints I'm going to connect and what will be the throughput, and then decide based on that.
Right. Yes, definitely yes. So how many servers you are going to connect on this port? But generally you will say like this is 48 port, 48 into 10, like 480 gig. 480 gig. So you never know maybe in the future you will connect more port, right? So it actually depends on how many server you are going to connect on this leaf. So let's suppose as of now you are going to connect only 24. So why would you connect? You will put your uplink 480 gig, right? So you will right now plan accordingly with 240 gig port, 240 gig of traffic. So how many server you are going to connect on your leaf? Let's suppose you are going to connect all these servers to 48 ports of 480 gig, and then distribute the traffic towards this spine.
Okay, thank you.
Just suppose so much traffic is going on through our fabric, so we need to increase the spine in fabric to increase our bandwidth utilization.
So yeah, not need to increase the spine. So actually each leaf has a 4 uplink, 40 gig into 4, so 160 gig, or sometimes 100 gig port. So 400 gig, maybe it will support it. So it depends on the uplink, how many uplinks you have. So now it means you don't need a 4 spine to accommodate 400 gig. You can connect a 2 link from this leaf to this spine.
So these 2 links in the port channel, or is a different port?
It will be clubbed into the port channel, but you don't do any configuration. It will club into the, if it's going to the same spine, yes, it will be in the port channel, and it will do the hashing.
Okay.
But we don't generally do any configuration. It will be automatically done by the APIC. Okay, so ACI technology, there is a vPod concept, virtual pod. Basically, this virtual pod meaning you have a on-premises data center, and you have a remote location somewhere where you don't want to deploy actual spine, actual leaf, right? But you still want to manage through the same APIC cluster, right? So this APIC cluster will manage the virtual spine and virtual leaf. So this is on the hypervisor, and the hypervisor you will create a virtual spine and virtual leaf. But in now, if you are saying, can I do it without the on-premises data center? No, you have to have one physical on-premises data center. Through that you will connect your virtual vPod. Okay. Otherwise I will build this lab and will do a more practical, but this on-premises data center should be, it's a must for the virtual pods. Okay, this is one of the other technology. Remote leaf is another technology. Let's suppose it's a remote part where you don't need a spine, you just need a server connectivity, right? So in that case you can connect a remote leaf. So in this case this leaf will be connected to the on-premises spine, right? So this is dotted link, you see. So under this spine, now I can say 1 2 3 4 5 6, total 8 leaves are connected. So these 2 leaves are not directly connected to the spine. These 2 leaves are connected via remotely to the spine. Okay. So like that, there are different technology, ACI and SD-WAN integration. So this mainly use, it's not that widely used, but it's helpful in the QoS marking, right? So you are doing a QoS marking from your on-premises data center till to the SD-WAN branch, then that will be helpful. So meaning you have a New York data center and you have a branch in Chicago, and you want a QoS for that packet end to end. It's the same, meaning whatever the QoS you apply on the data center should be the same QoS in your SD-WAN fabric. Then you can do this integration. Otherwise you can do it manually, but with the help of SD-WAN integration, a single policy will push to your on-premises or your data center as well in SD-WAN fabric. Okay. And I had never got a chance to work on this integration, as I said, right? Because most of the customer either don't want to integrate this, they want to manage separately SD-WAN fabric with the ACI. But yes, Cisco is slowly I think is moving towards this integration, right? NIR, we have a discussion, right? That it's used for analytics purpose. There is one NIR and NIA component which will be set on every leaf and spine, and which will send the data to that application, Indeed application. Okay, Nexus dashboard application, which is used for the analytics. Multi-pod, we have covered it, like, but not, we will definitely cover in more detail, but this is one of the other technology. MSO is another one. Now, standard L3 out. So L3 out is like if you want to connect you want to run any protocol, OSPF, EIGRP, BGP, you will have a router connected here. So that connectivity is called as L3 out connectivity. So this we will discuss it, L3 out. This one is golf. I think this setup looks to me similar like golf. Connected to the outside using layer 3 VPN service. Yes. So yeah. So this is nothing but you are expanding your VXLAN from ACI towards the ASR 9K. So in that case, you use a BGP VPN. I think someone from this one asked me this question. I'm not sure if it's a Sachin or Sumit.
Yes.
Right. I think Sachin, you right, that if you can do a MPLS L3 VPN handoff or not, right?
Yes.
So actually, this is the old slide. Actually, I should update it. There is one more technology, SR-MPLS handoff, segment routed MPLS handoff. Yeah, native MPLS handoff. So in that case, from L3 out you do a handoff. Now in case through spine you are doing handoff, but in that case L3 out, through L3 out you will do handoff. SR-MPLS handoff. Okay. So service graph, we touched upon this technology. Like you want to migrate client EPG to web EPG traffic, you will create a service graph. Basically, create a PBR contract which will redirect the traffic towards the firewall. Okay. Now we will discuss definitely more ACI VMM domain. This we will discuss what is that, and then the L2 out. Right, you have a Nexus fabric here and ACI fabric, how you will integrate. So if I want to club this all the technology of ACI into the group, right? So actually I have created this table just for the sake of my understanding, and I thought I should share it with all of you. But this technology group can be divided into three major topics. One is AP cluster and fabric, one is integration, another one is learning and forwarding, right? So now what we will do, we will definitely do this to bottom one, log analysis, RCA log analysis, RCA configuration, we will do it. Cluster configuration, we will do it. VMM integration, we will do it. Routing and multicast, EPM, EPMC, we will do it. L4 integration, we will do it. Multi-port forwarding, we will discuss it. We will not do it in detail. Golf forwarding, no, we will not do it. Off-flex issue on fabrics, yes, we will do it. Kubernetes and container integration, no, we will not do it. OpenStack VMware integration, no, we will not do it. SCMM integration, no, we will not do it. Yes, this we will discuss. This we will do it. This we will discuss it. This we will discuss. Right. So why I put this slide is not to confuse you guys, just to let you know, just to tell you that whatever we are going to cover in the ACI, it's not the end, it's just the beginning. And there's so many things you can do with the ACI, right? So, but my recommendation is if you start doing the complex thing like OpenStack VMM integration or Kubernetes container integration, or if you start studying the multi-site and multi-port before you understanding a single fabric, I'm 100% sure you will end up with nothing, right? So my recommendation is just start with the single port fabric and then slowly move into the complex topic, which is VMM integration, service graph integration. And then if you are interested and if you are good in the Kubernetes and if your organization is using Kubernetes and container, then do this integration part, do this OpenStack integration. If you are planning to migrate to the multiple site in your region, learn this multi-pod in more detail, learn this multi-site, right? But before you learn the single port fabric, if you jump directly to the multi-port or multi-site, you will not understand anything about the ACI fabric. Okay, so that's and our first session. Any question before we just close this module number 1? See, module number 1 is, I have not discussed any technical thing. It's just all about the ACI. If I want to quickly show you once again, like what we have covered in the module number 1, just to like why Cisco ACI, we know it, like spanning tree has its own channel, VXLAN its own thing. Cisco ACI resolved like faster, efficient, and this, right? Then we discuss about the epic, little bit about the epic. Then we discuss about the policy, how the policy is meaning the configuration. From the epic, you push the configuration to the leaf. You cannot directly create a policy on the leaf. You need to come on the ACI to create the policy, right? Now there are different type of policy: consumer, provider, contract, service, graph, web application. What are the best practice of creating those policy? Yes, and yes, we will discuss in detail. Don't worry about if you don't get it, because we have not discussed this policy model in more detail. We have not discussed even the epic in detail. We have not discussed anything about the cluster. We have not discussed anything about the cluster convergence or DME or different processes running on the epic. That is our next session. Then we discuss about Nexus series of switches, 9500, 9300 switches, about their generation, like Broadcom ASIC, first gen, second gen ASIC. How it is useful in case of troubleshooting. If you know you are troubleshooting the Gen 1 switches, which is Tahoe based, what are the commands you need to put in? Instead of a Rocky, you will put a Tahoe. Instead of Tahoe, you will put the Rocky. Otherwise, the command remains same, right? Now, then we discuss different, what about the fabric, ACI fabric, and then the different technologies of the ACI, right? So any question before we take a break and then jump on our module number 2? Yes, guys. Any question?
Yeah, the epic the hardware, right? That's a UCS blade server, or what is that?
UCS C-series server. UCS C-series server. And yes, our next session is about the epic only, and we will discuss this all in detail. Yeah. Actually, we have not discussed anything about the epic. What we have discussed is epic, what epic does and how, but we have not discussed how you will put the epic in the cluster. What are the, so this is our second module. So it's just give you the high level overview what we are going to do in this block series. We will do the policy, we will learn the ACI, epic, switches, configuration, and all those things, right? So yeah, any other question, guys, please?
You said like we can use in the same, like in two different VLAN communication can happen, and it will there will be no L3 devices required, right?
You mean VLAN 10 to VLAN 20? Yes.
Yeah,
Yes.
right. So
Yes.
there is no L3 devices required in between that, like if we wanted to communicate them.
So L3 device, yes, you need. But if it is a broadcast, then it will go to the, see, VLAN 20 device, definitely it will drop it, right? Because it's not for him, it's coming from different subnet. Meaning 10.10.1.1 is sending some broadcast. It should not go to that subnet which has 20.1.1.1. What the 20.1.1.1 will do, it will just drop it, right? It is not for him, it's coming from 10.1.1.1. But in ACI, it will go for 20.1.1. 20.1.1 will drop it. Definitely, it will drop it. It will not reply to that broadcast request. It's just a waste for him. Why should the VLAN 10 traffic should come to the VLAN 20, right? But in ACI, it comes. That is what I'm trying to say.
So what's the benefit of that? Like if it is coming,
actually, there's no benefit. The benefit actually in ACI, the broadcast domain is not the VLAN. The broadcast domain is your bridge domain. BD, So under BD, you can have a different EPG. So one EPG is VLAN number 10, another EPG is VLAN number 20. So EPG 10 is sending the traffic. It will be broadcast into that BD. So, but you can change it. You can change it to only to the inter. Okay. If you want key EPG 10 traffic should be only in EPG 10, not to the EPG 20. You can change that configuration, but by default, it is VLAN 10 traffic will go to the VLAN 20.
Okay. And one more question I have, like we talked about the VLAN and VXLAN, why it is required, like it will be increasing the number of
LAN segment, yes.
LAN segments, like
Right.
from 4095 to 16 million. So
Yes.
how we are going to do that, like 16 million, like I'm not able to understand how it is.
No, so
integrating.
yeah, so I understand, like you are telling me, hey, on the server side, we can only assign VLAN number 10, right?
Right.
We cannot assign VLAN 9787, some random number greater
Yeah.
than the 4K, right?
Right.
That is what your question. But
Yeah.
you know, the VLAN number, how you are creating 16 million LAN segment is like VLAN number 10 for customer A and VLAN number 10 for customer B is different. For customer A, it's VLAN number 10. For customer B, it's the VLAN number 10. But for our ACI switch, it is we need 1, 2, 3, 4. It is we need 4, 5, 6. It means they are two different LAN segments for us. But customer can use only 16 4K LAN segment. It means on the server side, I can still have 4K VLAN. But in a data center, you can have 16 million LAN segment.
Okay. It's still, like, practically I am not able to see what's the figure of that.
Yeah. So see, earlier VLAN number 10 for customer A and for customer B. If customer
Right.
B same VLAN number 10, it means customer A broadcast will go to the customer B VLAN number 10, right?
Right.
But you don't want that.
Mhm.
Now, how you will do it? Create a separate LAN segment. How you will do it? Customer B ko I will give VLAN number 20.
Right.
So, but in a data center, I can create maximum 4K LAN segment. But if I use a VXLAN, I will give a one. We need to customer A 1, 2, 3, 4. Customer B 4, 5, 6. Right? Now it's a different LAN segment for me.
Okay. So same VLAN we can give to customer A also. Same VLAN we can give to customer B also.
B also, yes.
Right. In
Yes.
that way we will increase it.
Right. No, and also like for a customer A, VLAN number 10. Now you are creating another VLAN number 10. Now you want VLAN 10 should not communicate with each other. Create a separate VNet for them. How you will do it in ACI? I'll tell you. You create a separate BD for them. Right.
Okay.
So then you can do it. In your traditional Nexus, under VLAN you used to define, right? VNI is this one. Over there you cannot do it, but in ACI you can do it, and
Okay.
that's why you can do it in the cloud as
Okay.
well.
So
in the
sub-bridge domain is the number, like, where we can segregate the LANs.
yes, so that's why your broadcast domain is your BD, not your VLAN.
Okay.
So in the cloud network, see, think about in the cloud, there are so many customers, right? And every customer wants to use, let's suppose, standard 1.1.1 or VLAN number 10. Now, how the cloud is, Google is doing it, right? Or how in the public cloud they are doing it. They are creating a separate network for each of the customer, separate VPC network for each of the customer. And this VPC cannot talk to this VPC. How they are doing it, right? They are basically doing it with the help of the number, the VNet number. And if this number is same, then only they will be able to talk to each other. Otherwise, they cannot talk to each other. But if you want, they can talk to each other, right? With the help of a one router you will place in between.
Yeah, right. Okay, I have one more doubt. Like, we have one, like one of the users are asking, and when they ask, like, they are giving us the IP address request they are asking, and I was thinking, like, in Amazon, like Amazon Web Service, or these are the clouds. What, like, these are the clouds, and they are providing us services, like storage services. Like, if we are asking from them the storage services, we need this much of VM they are providing, right? So
Mhm.
like how they are managing it, like they don't have the Cisco equipments in their environment, like they are having some different, like their proprietary equipment they are using for providing the storage and all, like
Storage, if I'm not sure, but for um, is this equipment, equipment, I think they are using a proprietary, their own
yeah,
switches.
because some of the users come to me like from my organization, and they ask me the LAN segment, the details, and but the detail, like we are managing it from Infoblox, one of the tool, but like however that the name convention is seems to be like IMI, like that like the tenant name what we use in ACI. So that's why I was have a doubt, like they are also using ACI in cloud. That was the doubt with me, like
No,
I
for
don't know.
sure they are not using ACI, because if they were using ACI, we were definitely got the opportunity. But so far I know the terminology wise is very different, same, meaning the concept wise is same. The
Okay.
tenant, the VDC, the VRF, and the EPG, everything is exactly the same.
Okay.
Okay.